hard to follow free beer after this. So I will focus my attention in our discussion for the next 30 minutes on how software is the most important thing for creating the new experiences and the sizzle that you get out of mobile silicon. Although being outside for the past few days, walking around Boston, I think the sizzle is on the streets there. But let's get into it. So let me put you in the shoes back in 1965. You're a relatively new engineer. The integrated circuit was just developed about 7 years ago, and you have an assignment to come up with a projection of how many transistors we'll be able to stuff into an IC over the next few years, over the next decade. Well, that's when Gordon Moore penned his seminal paper on the progression, the exponential growth of transistor technology, and be able to squeeze more and more transistors into the same die area, same cost, and really ushering in the revolution that we've all been able to take advantage of. I don't think I see anybody out there that was probably born in 1965, but we've all been able to take advantage of this in our own lives. And in particular, let me just walk you through some of the way that that's evolved in terms of devices. So going way back to Intel's first commercial product, the 4004, which was used in a calculator of all things, it had about 2,000 transistors in it. You leap forward to the first PC, the 8088, about 30,000 transistors. You can see the process technology progressing according to Moore's law. The Pentium processor with MMX was one of a watershed products, now in the millions of transistors on the die, getting up to what's available today in marketplace, the 5th generation core processor with close to 2 billion transistors on it using 14 nanometer technology. It's really amazing if you think back and say, this is what's happened over this time frame, and that the projections that Moore was able to do with that time frame in 1965 has stood up to that test of time. Now, obviously, this is not a physical nature of law of nature that, like gravity, we know will always be there. But the industry has been pushing forward. The economics have made it happen, and the capabilities that we've been delivering as an ecosystem have been the success for that. But it's not stopping there. I'm not going to project out the next 50 years, but just 5 years out in the future. Many people have been projecting out in terms of devices, services, as well as storage. And relatively consistent numbers are around 50 billion devices by 2020, being serviced with trillions of API calls, as well as 35 zettabytes. If everybody doesn't recall what a zettabyte is, that's the equivalent of 35 billion terabytes. So that's the amount of storage that will be available, accessed by all these devices in that time frame. And it's critical that software plays, the critical role that software plays to make those experiences across those devices is our responsibility to deliver that. But let me just give you some examples of where maybe it wouldn't be so great if software didn't do a good job. If you have an Apple Watch and the designers of the Apple Watch said, well, we don't need a touch interface on this, and maybe we need a keyboard to interface to your watch. That would kind of suck. It wouldn't be a very fun experience to have to carry around your keyboard. I'm personally excited, maybe anxious about autonomous vehicles. I think there's a lot of opportunities there. But it would be a pretty bad experience if you're sitting in the back seat of your Uber automated car and all of a sudden it crashes. It kind of gives a new meaning to the blue screen of death. And when I'm flying out of Logan tonight, I'm really hoping that the air traffic controllers are using more than pencil and paper to track where all the airplanes are flying in and out. Software is critical for delivering the analysis, the user experience, all those things across this entire spectrum of capabilities. And I'm not the first to say it, but silicon without software is just sand. Actually, it's really expensive sand, and it's really hot sand. And we need this software to deliver the great experiences on top of it. So for Intel, our corporate vision is if a device is smart and connected, it runs best on Intel silicon. That's our motto. That's what we do with every single person in the corporation is focused to make that happen. And software is critically important to making that vision a reality. When I talk about software at Intel, people often think, oh, well, of course, you're writing the drivers, or you're writing software so people can do chip design. It goes way beyond that. And here's our classical software stack. But Intel plays a role in every piece of this stack. And I'll go through some examples of them to kind of highlight those capabilities. The first thing is really and why does it matter to us? It's really to help amplify the benefits of Moore's Law. By creating optimized platform software and working with people in the ecosystem to create optimized apps, as well as exposing new platform capabilities and having effective developer tools and programs, this really feeds a cycle of people to create lower cost platforms, bring your applications faster to market, longer battery life, better experiences, deeper insights in your analysis of big data. And all those things play off of each other, and that's why software is a critical piece in Intel's overall strategy. Last year when I came here, I had a similar slide, and I talked about how Intel fully embraces Android, and we work really closely to make that a great platform. And I got a lot of quizzical looks. People said, actually, Intel's in Android devices? And if you haven't been to Best Buy recently, I encourage you to walk through there and take a look at the tablets that are in the marketplace. Many of them are Intel-based platforms, including this nice Dell Venue 8 that I have here, that we are also giving away at the Intel booth. If you go and talk to some of the very nice people there, you'll be able to register for winning one of those. We're also the #1 merchant supplier of tablet apps processors. This means Apple, they make their own processor, so they're not a merchant supplier. But for all the SoC vendors that are developing tablet apps processors, over the past few quarters, Intel's been the #1 supplier. And we also have over 200 designs of tablet and phones worldwide. It doesn't stop there with just the hardware. We work very closely with all the operating system vendors. Windows 10 obviously just came out earlier this week. We work very closely with our friends at Redmond. Same with Mountain View, Cupertino, all those operating system vendors we work very deeply with. On the Android side, we were first to deliver the first 64-bit kernel. We're also the top contributor for the Linux kernel. And we also deliver solutions like our crosswalk optimized runtime for these platforms. So again, this is really where software is critical for Intel. The other part is how do we help to create new experiences on these platforms? And the one that we've been focused a lot on over the past few years is something known as RealSense. It's basically a technology that adds 3D depth cameras to your devices, including tablets. So this device here has a depth camera on the back. So you can get 3D information from your images, use that for doing things like scene capture, virtual reality. It's also thin enough that it can fit within the bezel of your laptop for user-facing information. So you can do gesture control, facial recognition. All those things are some of the experiences that are possible. And again, it's driven by the miniaturization of the technology. So here's just a look at the actual circuit board with the IR sensor, your standard 2D camera, and all that's fitting, and you can see its comparison to a US quarter. That allows it to get into these devices. The work that we do at Intel is provided a software development kit, or SDK, so you can have access to that information to create your own applications for doing things like scene perception, object tracking, virtual reality, and all those things are part of the middleware solutions that we bring to market. And then we also have a variety of software developer tools. And I think most of the people that I've spoken here are developers, which makes this a fantastic conference. You're speaking with fellow developers and able to rub shoulders with them. And we span a set from client developers, people that are developing for mobile devices, PCs, our XDK, which is really focused on HTML5 developers, as well as a product that we refer to as Indie for native development. I'm going to talk more about both of those in a few minutes, so let me kind of put those off to the side. We also have, for people doing high-performance technical computing applications, the Parallel Studio XE is a flagship product that we've had for a number of years. We also support people doing video processing, video codec development, applications like video over-the-top transmission with our Intel Media Server Studio. And finally, System Studio is for people that are really doing deep-level analysis, debug, system bring-up across operating systems. So that's sort of the gamut of our developer tools. And then we also have a single source where you can get access to all this information. It's called the Intel Developer Zone. You can get all these tools available there, articles, code samples, kind of interact with Intel experts as well as other peers in the industry, and then also some business resources so you can get co-marketing opportunities and funding opportunities. I highly recommend you to go there as your starting point, the URL, super simple, software.intel.com, and you can be part and access all this information. So that's sort of the high-level view of what software at Intel is all about. Now let me go into a very specific area around solutions that we see are critically required for the multi-OS world that we all live in. So first, just some business data to kind of help motivate the need here. I'm showing some numbers of installed base. This isn't the number of devices that are sold per year, but the number that are actively being used in the marketplace. So that's why you can see an astronomical growth on Android, as well as iOS and OS X devices, but also a healthy environment for Windows platforms as well. And we'll see what happens with Windows 10 coming out, as well as universal apps. But the point being, it's not just one operating system. You can't just target for one. You have to be developing your solutions to span these environments. And the marketplace does that. Specifically, the mobile market app developers have realized this. Everybody's really smart. We say, we got to do Android, and you got to do iOS. And it's pretty much a neck-and-neck horse race between them. You know, depending on which quarter you're in, which one's ahead, they're roughly about the same. And the reason why they're so close is everybody realizes you can't have your application only on one of those platforms and not the other. To me, though, there's been a lot of wasted work developing both across these ones. They require often different technologies, different tool chains, and a lot of effort and different skills to make those a reality. So there are solutions to help here. If you're an HTML5 JavaScript developer, Intel's got a great solution. We call it the XDK. It's an all-in-one development environment for those platforms. It goes from code editing to debug, emulation, testing, and deployment all within this single free tool available. On-device debugging support, memory and CPU profiling allows you to create responsive applications, accessing many of the capabilities on the platform like sensors and cameras and other features, and then a one-click build environment so you can target both web applications as well as hybrid apps that are then deployed in stores like Google Play and the App Store from Apple. So if you haven't used it before and your development language of choice is HTML5, this is a fantastic solution for you. Not everybody is an HTML5 developer. Some people code more in the native environment for those platforms. However, the typical environment that I see is there's typically, unless you're a one-person company, you have your Android team. This team typically consists of somebody that's doing the UI design, a bunch of Java developers. You're all working in Android Studio, and you've either made the choice of everybody's working on Mac systems, or you've got Windows development systems, or maybe some mix between them. And then you've got on the other side, maybe across the hall, maybe a different building, maybe around the world, wherever they may be, your iOS team. You've got people that are doing the UI design for that, a bunch of Objective-C and Swift experts and developers. They're all working within Xcode, and they've got a bunch of, obviously, Mac development systems. That's great. You get two apps out of it, but oftentimes the feature priorities aren't identical. So you might have one feature available in this release on this platform, but not another. You've got different code, which causes different defects. You've got different release cadences, and you also have different team skills. So if one app is lagging behind the other, it's hard to bring over all the Swift and Objective-C developers and have them do a lot of code in Java. Now, often people can help out, but it might not be their best skill and the best use of their capabilities. So here now, let's imagine a world where we just have one team. Everybody's coding in Java. We're all working on an Android Studio. You can choose. Everybody either works on a Mac system, or everybody works with their Windows system, or if you want to have some mix and match, you can do that. And you just have a thin little bit of work that's working on the UI layer, that's focused on giving a native experience, native look and feel on Android or iOS. This allows you to have one logic code base. You're developing in one language. You can use one IDE and one development system to create both your Android and your iOS app with native look and feel, performance, and full access to those capabilities. I'm really happy that everybody's here today to share in this, because we're going to be showing and launching technology that allows you to do just that. Let me first show you it in action. And let me describe it here first before I switch over to the development system. So if anybody lives in Boston or been here for a long time, it was notorious for stolen cars. A lot of stolen cars were in Boston. I hear that it's been improved quite a bit, but we felt that would be a fun app to make, which is basically a car hunter, we call it. Our partners here, a company known as Midron, developed this technology using this solution that I'll be describing in a minute. Basically allows you to take a photo of a car, it does an automatic recognition of the license plate, and then it goes back to a database and sees if it's in a stolen car database. And it'll tell you, on my Android device over there, that plate was found, but it's all good, it's not stolen. And then the Android, or the iOS one, different car, that car actually wasn't stolen, we put a fake license plate there. But it would show you that it was a stolen car. So that's the demo of it, or that's how it works. And let me show you how we can make this happen with this technology. And OK, there we go. So if I can switch over. OK, so I've got a Windows system here. I've got my Java code, same code that I run on my Android device that does this car hunter. I've got my iPad connected over USB to the device here. Application's not on yet. I put a breakpoint in there when I open up one of the buttons. So I'm going to hit the debug button. You can see in the bottom window that the build started. We're actually building over on this Mac system, so you can do it over a networked Mac system to do the final build. It's doing that, and now it's starting the initialization. And then it should come up here soon, if everything works well. There it is. OK, so now we've got the same exact app logic between these two platforms, Android and iOS. I can hit this button here for look at existing car. And did I remove the breakpoint? Uh-oh, Dimitri, we might have. Do we remove the breakpoint here? Click on the button. Yeah? No. All right. Demo support. Let's come up real quick. I hit the wrong button. Sorry. I hit the run, not the debug. I'm sorry, folks. My eyesight. All right. We'll let that go. But the basic story here: we are working on our Macs, or our Windows system. We're able to do on-device debug on that from our iPad system, all using Java code. We've got a thin layer of difference between the UI code, so it has a native look and feel between them. OK, so now it's restarting here. OK, let's see if this does it this time. OK, there we go. So now I am into the code, and I can step through. I can see all the different variables, all the code, just like you would do in any debugger. So not going to go through that at length. But you can see that we're able to do this technology and to run this all utilizing my team's Java expertise on the platform of choice that we wanted to develop on, and to create both an Android and an iOS app really seamlessly. So let's go back to here. So the question is, well, how much code am I actually able to reuse? This analysis tool, again from our great friends from Midron, developed. It allows you to look at both the UI code logic as well as the UI code as well as the logic code, and to analyze how much is directly reusable between them. The overall application for this one is about 95% portable. The UI code much less, as you would imagine, but 100% of the logic code is reusable. Doing a little bit of calculations, assumptions around how much a developer can code in one day, we come up with about 6 to 7 months of savings for creating the iOS application using this versus starting fresh and developing the Objective-C code in that manner. So that's sort of, if you can take the real world example and bring that back to you. If you want to be able to load up your own APK to see how much you'd be able to get reuse, it's just analyzer.midgeron.com, and you can get more detailed analysis as well as consulting help and other training for that. So what we're really announcing is the availability of this new capability. We call it our multi-OS engine. It's part of our product suite that I've mentioned before, Indy. The main features are that it allows you to create these Java-based iOS apps. You can develop and deploy on either Windows or Mac within Android Studio. You can create a native UI within Android Studio or using Xcode, whatever is best for your needs. You can do debug on device as well as simulator. And it allows you to get full access to the Objective-C language features as well as full iOS platform APIs. We do this with a binding solution. So we do language binding, and we do that for the entire iOS API, as well as if you have your own libraries in either Objective-C or C code, and allows you to create that automatically yourself. So you can access all that information from Java code. You actually can avoid some of the intricacies of J&I and bring that to your product. So we just did like a little comparison. There's obviously multiple multi-OS solutions out there. They all have their strengths. They have some differences in their approaches. I'm just going to highlight our two that we talked about here today, the Intel XDK. If you're an HTML5 developer, uses a runtime Cordova. We don't require learning any new third-party API. The one sort of trade-off is you don't get a full kind of look and feel, the native UI, but you get full UI code reuse as well as logic reuse between them. And then this new multi-OS engine is utilizing, if you're a Java developer, as your solution. We use an ART runtime from Android, so you can kind of trust that, that technology as part of the solution. Again, you don't need to learn any new third-party API. The one trade-off here is you don't get full 100% UI code reuse, but you do get the full native look and feel. So that's the trade-offs between those two solutions, as well as what your programming language of choice is. So to kind of loop the whole circle here, we did that same analysis on the top 25 games, non-games in Google Play. Just grabbed all the APKs and said, if they had started fresh, didn't create an iOS app yet, and wanted to from the Java Android app that they have, on average it's about 60% code reuse across the entire application. And the math, you can probably argue here, I'm stating you can probably save a few developer years of effort to create the iOS app if you'd use this technology. Now, your results will vary. Your mileage varies here, depending on how well you've separated out your code, how much logic you have there, how much library you have. But this is just a frame of reference for you to understand the value that this can bring to your own development and your teams. So the call to action here really is, first start out, no matter what you're doing in terms of tools or whatnot, to develop your application, architecting out the UI code from the app logic. It's simple, clean, makes for easy porting between them. Then use the right tools that match your skills and needs. If you're a Java developer, we think this multi-OS engine capability strongly fits that. HTML5 or XDK would be a great solution for your needs. If you're interested in this multi-OS engine, if you're a Java developer and you want to bring your app from Android over to iOS, we have a new controlled early access beta. We're literally launching it today. You folks are the very first people to hear about this. So you get the first chance to sign up for it. And we're just kind of starting this out so we get some early engagement with people, get some feedback, and make sure it's a really rock-solid solution before we go more broadly. And then you can learn more at the Intel booth. We have an XDK class tomorrow at 11 a.m., and then an Indy class where we'll be going through more details, the technical underpinnings of this solution at 2:45 tomorrow. So with that, I'm not sure if I'll still be here 50 years from now, but I know in the interim we will be creating great stuff together, and it all starts with the software development that utilizes the platform that's based on Moore's Law. So thank you very much for your time, and I'm open for any questions that you have.
All right.
So what's the difference between your solution and, for example, the existing RoboVM, which is exactly the same approach of getting the Java VM on an iOS device?
Great question. So what's the difference between this and RoboVM? Very similar objectives and goals. The difference mainly is the runtime. So they're using a proprietary runtime. This uses ART as the runtime.
And do you support the OpenGL stuff as well? Like, for example, could I use your solution to create in Java a game and can deploy that to iOS, or is that right now not possible?
Yes, you can do that as well.
Okay, thank you.
Yep. Great question, though. You definitely understand the technology. That's good.
So the code generated by this Intel tool, what is the performance difference between the native code versus the code generated by your tool?
Great question. Our experience has been that it's on par and even sometimes better than the native Objective-C, where if you don't have a lot of dispatching, if you have a lot of dispatched code, the precompiled, ahead of time compiled Java code will be faster than the Objective-C. Now that's not always the case, but it's right at the same level.
Questions? There we go, over there.
We also have two ends here.
Okay, I'm going over here first, then you. Ready?
Just don't throw it at his head.
Wondering what limitations, specifically like the render script, other APIs that I'm not sure they would be supported on iOS.
Yeah. So what is our full, I'm looking at some of my full technologists here just to see if I can get a little support on that question. So, Peng.
All right, so yeah, we are not bringing the whole Android systems framework stack over because otherwise it'll be way too big. So essentially on the native performance, native look and feel and the device side, we provide you full access to the iOS APIs there. So the render script stuff won't be able to port over.
Thank you. I have two questions. The first one, the APIs are different, and some of the APIs available on Android are not available on iOS. An example, the MDN, MZ. So how you are going to address these limitations different between the APIs? Second question, once I build an app using this tool, then how can I test it on an iPhone, an iPad, or an iOS emulator?
Sure. I think the first question was sort of, I think, addressed by the previous one, where we don't have full API support across them. So some of them, that's part of why it's not 100% reusable. In terms of testing, you can definitely debug and do all your testing directly on those devices. So the application will run natively just like any other IPA on your iOS device. Were you asking about like a test infrastructure or debugging and? Yeah, just like the example I showed here, it was plugged in system, debugging it from here on this iPad. So this is an iPad. Yep, great question. Yep.
So I'm interested in when there are additional APIs that come available, like you showed, you could thunk into C code, for example.
Yeah.
I assume right now we're somewhat dependent on what you have built in, but is there an easy mechanism for us to basically build against other APIs?
Yeah, that's great. Yeah, good question. So I alluded to it quickly, but a little bit deeper description of it is we have something we call NatJ for native J. It's an automated binding tool, which allows you to for us to bind all the iOS Objective-C libraries. So we've already done this for iOS 9, for example. So as soon as the latest next version of iOS comes out, we're able to do that in a very automated fashion. We also supply that tool as part of the solution, so you can bind your own APIs in that. So you can kind of be up to speed and not have to wait for us to help that for you.
Hi. So you mentioned that like 100% of the logic code was reusable, but not the UI code. So if I have to write my iOS code, the UI, can I use like interface builder with all the auto layout magic in Xcode, or is there like a new language that now I have to use to write the iOS code?
You don't need to write any new language for the iOS UI code. We do supply what we call a UI builder that you can run in Android Studio. to do your layout and basically gives you the look and feel of the iOS widgets, and then it translates over to the storyboard in Xcode. Or you can be working directly in Xcode and have your UI designer just work there and plug in the UI code. So those are the options that you kind of have in front of you. Yeah, hopefully that answers it.
Hi, I have two questions for you. The first one is about obfuscation in ProGuard. Is that going to work well, continue to work well for the Android APK? And where do I get it? Is it the same version of Studio that I'm already using, or do I gotta download something from your site? Am I gonna be whitelisted, or?
Yeah, no, so you get it from Intel. So it's not immediately available in Android Studio. So it's a plugin that you provide, and you install that.
Studio plugin, gotcha.
Exactly. And then your first question on ProGuard, I'm not sure if I followed that question.
ProGuard is the tool that we use to obfuscate and encrypt APK files before we put them on the Android stores,
right,
so that they can't be cracked so easily.
Right. So your Android app doesn't change at all through this. So there's no change in your tool chain and how you're creating your Android app. So yeah, continue to use everything you're doing there. This is really for taking that now and bringing it to iOS.
Does ProGuard apply in the? It does. Okay, thank you.
Thank you. Thank you, Paul.
Is that it? No more questions? Oh, one more. All right. I think we have time for like 2 more anyway, so. Ready?
Have you thought about how this will play with the mobile device management, like enterprise management tools, like Mobile Iron or AirWatch? Because some of those have problems with Android, and they have no problems with iOS. So if we're building for Android and porting to iOS, it seems like we might be actually making problems for iOS.
Making more of a challenge, yeah. I personally haven't. I'm not sure if anybody in my esteemed colleagues here have thought about that. No, so I think we need to sounds like we'll need to figure that out, but no, we haven't really thought about the enterprise environment where it's got a lockdown.
Okay, is it easy just to make like, the other is a totally random question, for databases, like in-memory databases, like, is that easy to translate over? Is that part of the?
Yeah. I mean, is there something specific on the database?
No, just in general, because I know Mobile Iron, if you make a database using SQLite, you have to make it in programming, as opposed to making the schema and then having it as a package that's part of the IPA.
Okay.
Like, you have different problems that way, so I didn't know if it's easy to programmatically make a database.
I don't think there's anything specific. I mean, the actual demo that the Car Hunter one has a database interfaces to it, and so we feel pretty confident that that's not a challenge, but that's exactly why we're coming out with an early beta here, to get some feedback and to understand if we miss some corner cases. So we'd love to have people using it, giving us feedback, and we'll make this and fine tune it to your needs.
Weird. So as the technology matures, are you afraid that Apple might be will do something to block this from their build framework, or are you confident that what you're doing is completely future-proof, basically?
You never know. I mean, Apple can do lots of things. They've put up big walls in the past. As somebody, I think one of the first questions pointed out, there are other similar technologies out there in the marketplace today. They haven't blocked those. We have good close relationships with Apple. We've discussed some of the technology with them. So far, not a problem. So we're confident in the solution. I can't, as I said in the beginning, predict full future, but right now we don't see any concern to make that happen.
All right. Thank you very much, Jeff. We don't have any more time for questions, but let's give Jeff a big round of applause.